So let us assume we have a sender on the Lightning Network who wants to send some money, let's say 300 Satoshis, to a recipient R. And they're both on the Lightning Network, but they don't have a direct payment channel between them. Since the Lightning Network is a network, the sender might have a channel to a node called N1, and this node might have another channel to a node called N2. This node N2 might have a channel to R. We assume already that all the channels have enough capacity to forward a payment, and I also write down the short channel ID. So we start by creating a message that basically contains the amount that is supposed to be sent to R. And we put this message into an onion envelope. There's actually a little bit more data inside this onion, and it contains a public information, which is the key R. So I want to talk a little bit about this key R and why it is actually needed. Our general goal is to encrypt the message inside this envelope. So we could have used the public key of node R and the private key of node S, the sender, to do an elliptic curve Diffie-Hellman key exchange in order to create a shared secret and encrypt this message. The problem then is that the node that is processing this onion would have to know that the message originated from the sender. The sender would have to reveal its key. This highly decreases the anonymity of the payment, since every node on the route would see that the payment originated from S. So what S does instead is it creates an ephemeral key or a temporal key that it uses for this particular layer of the onion, so in our case for the node R. So he uses this ephemeral key to do a Diffie-Hellman key exchange with node R, and it still has to reveal the public key that was being used to R, and he does so by putting it exactly on this message envelope here. Otherwise, R cannot do its side of the computation of the Diffie-Hellman key exchange in order to produce the shared secret. If that was too quickly for you and you're not familiar with elliptic curve Diffie-Hellman key exchanges, I highly encourage you to subscribe to my channel, because I plan to explain this in a separate video on more detail later. So then we extend our onion by creating another message, which again has the amount 300, but it has a short channel ID of 452, and we put this in a new envelope, and this new envelope is sealed, and again it needs to have a key, which is the key that is being used for node N2. Now this message again is getting extended. Since the node N2 wants to have some routing fees, the amount now will be 301 Satoshi, so node 2 will earn 1 Satoshi in routing fees, and the short channel ID is 74, which is the channel between N1 and N2. So this again is put into an envelope, and the envelope gets a public information, which is the key that is being used for Diffie-Hellman key exchange with node N1. And it's extended again by a message, 303 Satoshis in this time, and there is a short channel ID attached to it, which is 357. So now we use a red envelope. Red envelopes are the ones that are happening on a different part of the bold specification, which is bold 8, the transport layer, and also in this case bold 2, which is the peer protocol. And on this envelope we put the payment hash, kind of like a stamp on it. We say what kind of message it should be, so it should be an update add HTLC message. There's a little bit more metadata to it. I left this out in order to make stuff a little bit simpler, and we put inside this update add HTLC message the onion package, and we send this peer-to-peer message over the transport layer that is defined in bold 8 from the sender to node 1. So now N1 receives the message, opens it, and sees, oh, there's supposed to be an amount of 303 sent to me on this channel. So basically S and N1 set up an HTLC in their commitment transaction. An HTLC is basically a conditional payment where the condition is that the pre-image to the payment hash is known. So the payment hash from the envelope is part of the HTLC that is being set up. Don't forget to subscribe to my channel, as in future videos I will certainly explain more about the construction of payment channels and how HTLCs are particular outputs of the commitment transactions that are being used in the construction of a payment channel. And then there's also the encrypted envelope. Since this envelope used the key N1, the node N1 can decrypt the message, and it sees an amount that it's supposed to forward, which is 301 Satoshi, over a channel that it's supposed to forward, and it sees another sealed envelope which it can't open because it doesn't have access to the node. Now another HTLC is set up. This is again being done by putting this information into the update add HTLC message on the transport layer, where it's sent to node 2. And node 2 basically does the same. It opens this, it looks at the message and sees, yes, perfect, this is my HTLC, so it negotiates the HTLC with N1. It decrypts its envelope and it sees, oh, I'm supposed to forward 300 satoshis to the short channel ID 452. So a new HTLC is set up with the amount of 300. And again, in order to do this, of course, there needs to be sent an update add HTLC message. So this message goes from N2 to R, and R now opens the envelope and it checks that the HTLC is correct. So it decrypts the onion and R sees it has received 300 satoshis. And in particular, it knows that it should not forward this onion anymore because there's no other envelope inside. There is some metadata which I omitted that really shows that this was the message for R. And of course, R can only receive the 300 satoshis if it knows the pre-image to this payment hash that it originally created. And now we have to see how we can settle the pre-image. So let's assume the pre-image for this payment hash was 45A3B7, and we put the pre-image into another bold 2 message, the update fulfill HTLC message, and this is being sent from R to N2. R can safely release this pre-image because the HTLC is set up in case that a new channel state is not being negotiated between N2 and R. R can force close the channel and settle the HTLC on chain. Then of course N2 takes the pre-image and also wants to claim the funds because now it has paid R, so it wants to get reimbursed. It sends the pre-image via an update fulfill HTLC message back to N1, and N1 does the same by claiming the money from S, who was supposed to do the original payment. S can basically check that this pre-image really computes the payment hash, which any of the nodes should have done. So at this point, we see that all the HTLCs are being set up. They are being set up in the direction from S to N1 to N2 to R. The onion is encrypted in the other way around. So it starts with the message for R, and then comes the next layer with the message for N2, the next layer with the message for N1. And then we already see that N1 received 303 satoshis, but only forwarded 301, which N2 received, and N2 only forwarded 300 satoshis, which means that N1 collected a fee of 2 satoshis and N2 collected a fee of 1 satoshi. Whereas the sender needed to pay a little bit more, so the sender paid 303 satoshis with a total fee of 3 satoshis. Let me explain a few things about the privacy of the Lightning Network. If we go back to this stage of the video, where you can see that N2 already has decrypted its onion message and is about to forward another onion to R. The interesting thing is that N2 doesn't know that the onion really originated from S. It cannot know this. And also what it cannot know is that the onion that is being forwarded to R is really only going to R and not being forwarded again. One thing that I omitted in this video is that the onion messages are always padded with a little bit of random junk data, so that at all levels of the routing process the messages have the same size and nobody can really see anything. This privacy comes at some cost, because due to this privacy and the fact that the channel balance is also not public information, the source who is creating the onion packages just has to select a route, and it could happen that a payment channel doesn't have enough capacity in order to forward the payment. This is something that the critics will always use as a reason to explain you why the Lightning Network must fail. In my opinion, the routing becomes more and more stable as the Lightning Network grows. So over the last year, the routing success was just, in my personal usage experience, growing and growing. So I would not consider this to be a really big issue. Also, I want to emphasize that once the chain of HTLCs is set up, everything is enforceable on the blockchain, and before the chain of HTLCs is set up, nobody really takes a risk. So this is really a secure way of doing a payment. But one thing that you might have already realized is the fact that this entire process is a little bit complex. If you ask me, it is really hard to extract this information from the white paper, because the white paper pretty much only describes the cryptography of setting up a payment channel and creating HTLCs. It doesn't really talk about the transport layer protocol and about the peer protocol. Whereas when you look at the bolds, you can read the bold 4, which is the onion routing bold that basically describes the SPHINX mix format that is being used, which I kind of neglected here. But when I really was creating the video, I also had to look at the bold 2, bold 3, bold 5, bold 8, and technically also at bold 11. So all the bolds are also very much interacting with each other, which also makes them hard to learn from them. If you are new to this channel, you might not know that this video was made possible by this amazing community of Bitcoin enthusiasts who supported my first fundraiser that I could buy the document camera that I used in this video. Thank you so much for all these almost 30 people who supported this first fundraiser. Therefore, I want to encourage you to support my educational activities even further, because a camera is really great to record videos, but I also need time, which I can't use to earn money otherwise. This video, for example, took almost 2 days to create, besides the fact that I had to read all the bolts and had to understand the Lightning Network in the first place. You might know that I'm trying to create an educational book about the Lightning Network. This book effort goes hand in hand with creating more videos like this. So I would encourage you to check out my Telecoin page, where you can donate with Bitcoin or with Lightning Network payments. For those people who prefer to pay fiat and get rid of their fiat money, I also have set up a Patreon page. This would really help me a lot and motivate me a lot if we could fill up my fundraiser in this month to at least reach 1 Bitcoin in order for me to continue creating this kind of content.